This is question 2 from the 2015 IBMathSLY exam, paper 1, time zone 2. Let's take a look at it. So we have a trigonometric function. We are told that it is a sine function here, and we're told that b is positive. And we can look at the graph. And the first thing it asks us to do is find the period. Now, the period, you might remember, is the smallest length along the x-axis over which the trigonometric function repeats itself. So what I mean by that is we can sort of trace this curve and just figure out where does it return to where it started. Where does it start having the exact same pattern appearing? So if we take this part of the graph and we just sort of move it over, we can sort of see that this length does seem to be about right, because pretty much anywhere I drag this length, I can make it so that it overlaps another complete portion of the graph. So this width then of the curve, where this happens, is the period. So the period of this curve is the length of that function. And so if this right there is the distance along the x-axis it takes to repeat, we know then that the period is just going to be pi. Now the amplitude of f is the distance above the center line of this function that the maximum value is from the center line. So our 0, y equals 0, is the middle of this function, and we can see that this function reaches a maximum height of about 3 units. It also dips 3 units below that center line. Okay, and so this gives us the amplitude. This is what the amplitude represents. So the amplitude is going to be 3. Remember that amplitude is always positive. Amplitude is always going to be positive. Even though we might have this trigonometric function flipped about the x-axis, that doesn't change the amplitude. It just means that the outside function has been multiplied by -1 in some way. The second part of this question asks us to write down the value of a. Let's look and see where a is located. So a is right here in front of the function. What I had just said is that a value out front is related to the amplitude. The normal function of sine of x has a amplitude of 1. So normally we would expect the sine value to go up to 1. But we can see instead that y-coordinate is being multiplied by 3 to get up to this maximum value of 3. So that tells us that the a value must be 3. The other way we can just relate this is that amplitude generally is going to be this outside value, outside of the sine. Just as I was saying before, remember that that number could be negative or positive depending on what the sine function, or the cosine function for that matter, is actually doing. We can see that sine function normally just goes up right here for the first half of its period, and the function f of x here is just a positive multiple of that. All of the y-coordinates have been multiplied by the same positive value, which means that a is going to be 3. And the last thing is b. And there are a couple ways that we can look at b. Let's again draw what we know about the normal sine function. The normal sine function has an amplitude of 1, but it has a period of 2 pi. So this goes down. I did a horrible job of actually drawing that down to -1, so let's try that again. So right about there, and then back up to 0 at 2 pi. But we can see that for this function, f of x, the x-coordinates have all been divided by 2. Instead of a period of 2 pi for the normal sine, we can see that this function, as we found in part AI, this function has a period of just pi. So as a result, instead of a period of 2 pi. The period is pi. The x-coordinates have all been divided by 2. What does that do for a function? Well, one thing we might remember is that a transformation that leads to all the x-coordinates being divided by 2 is f of 2x. And so what we could do is say we know, therefore, that this has to be sine of 2x in order to reduce the period down to pi instead of 2 pi. The other thing that you might remember is that we have a little formula for period. The period t is equal to 2 pi over b, where this is sine of bx. And so since we've already found that the period is pi, we could just solve for b and get that b is going to be 2 pi over the period of pi, which also means that b is going to be 2. So either way you come up with it, you're going to get the method points and the accuracy points, as long as you end up writing that b is equal to 2.